Hey guys, welcome back to the channel. Today we'll be solving LeetCode 48, rotate image. So we're given an n by n 2D matrix, so it's a square, and it represents an image, and we want to rotate it by 90 degrees clockwise. And we have to rotate the image in place, which means we can't store another 2D matrix, and we have to use constant extra space. So in this example, as you can see, they rotated the image, and this row became this column, this row became this column, and this row became this column. So we can solve this in efficient time using an O of n squared solution with constant extra space by using some tricks that you can learn from linear algebra. Basically, we're going to transpose the matrix and then we're going to reverse each row. And anytime you see rows becoming columns, you should know that something is being transposed. So let's get into our explanation. So the time complexity of this solution is going to be O of n squared, and that's because to transpose the matrix, we have to iterate through the entire matrix, so every row and every column, and we have to swap the elements in place, so therefore we don't have to store any extra memory, and our space complexity is going to be constant. Let's start off by going through this example to understand what transposing a matrix will do. So we're start off at the first row and we're at the first column and we're going to swap, and this is just going to swap and keep it where it is. Nothing will change. Then we're going to swap 2 and 4, and then we get to 3, and we're going to swap 7 and 3. Then we get to the second row and we don't have to swap anything. We get to 5 and we don't have to swap anything. We get to 6 and we have to swap 6 and 8. And then we get here, we don't do any swaps. We come here, we don't do any swaps. We come here and we don't do any swaps because it's all in the correct place. And now we're going to do the matrix reverse. So we're basically going to reverse every row. So we start off at the first row and we're basically just going to reverse the elements. Then we go to the second row and we're just going to reverse the elements. We go to the last row and we're going to reverse the elements. And after that, we're pretty much done. We have rotated the image by 90 degrees. So let's get into our code. We're going to grab the length of our matrix. So this is going to be the number of rows and columns, and it's going to be n because it's a matrix and it's n by n matrix, so it's a square. And we're going to get the row first. Then we're going to loop through all the columns. And then this is where the swapping happens, and we can do this using Python's one-line swap. So at the current row and current column, that's going to become the column and row. So now this column is in the row's position. That's how the rows becomes columns, because the first argument, the first index is the rows, the second is the columns, but now we gave C instead of R, so we're swapping, and the columns are going to become the rows, and this is basically just going to swap them. And now we're just going to reverse every row in the matrix, and we can do that like this. And you can use Python's built-in reverse function. And this is pretty much all the code, so we can run it now. Looks like it worked and it's pretty efficient. Thanks for watching, guys.